Okay, this is the video for the review for the triangle proofs test. So here we go. We're given a few things here. We're given BC is congruent to DE. And I'll write that down in the proof. And if we know BC is congruent to DE, they ask us to prove that angle BGD is congruent to angle CHE. So before we do that, our plan of attack here is to prove the triangle is congruent. And so what we have to ask ourselves is, does BC being congruent to DE count? And the answer is no. Those segments are too short. BC is just this little guy here. DE is just this little guy here. So if the segments are too short, we can try to look to see if we can add something onto them, and we can. We can add this green segment, CD. But before we add it, we need to say it's congruent to itself, because we're going to add it twice. And that's the reflexive property. So when segments are too short, we have to try to add something to them. So step 3 here is I'm going to take BC and CD and add them together to get BD. We'll take CD and add it to DE to get CE. And then all together, we know that these pieces are going to be congruent. So BD is congruent to CE. And this is the addition postulate, or just addition. So that counts because now we have BD and CE fully congruent. Check it off. Again, we need 3 check marks to get the triangles congruent. So off to the next given we go. So number 4 says angle ABG is congruent to angle FEH. So here's angle ABG, here's angle FEH, and I'm going to take it upon myself to number them, 1 and 2. Those do not count because they're not in the triangles. They are, however, linear pairs with angles that are in the triangle. So I'm going to number this guy 3, number this guy 4. And what we're going to say in step 5 is that angle 1 and 3 are supplementary, along with angle 2 and angle 4 being supplementary. And the reason for this is that linear pairs are supplementary. That does not count. What we really want are the 2 angles inside the triangles to be congruent. That would be angle 3 congruent to angle 4. And different people have different ways of saying this. I'll just say it like this. If 2 angles, actually I won't say it like this. I want to say congruent angles. Some people have been saying this. It might be a little easier for some of you. Congruent angles, okay, have congruent supplements. That language might be a little easier. You could also say if 2 angles are congruent, then their supplements are congruent. You could say supplements of congruent angles are congruent. Just getting the point across that if you started off with 2 congruent angles that we have in step 4, their supplements are going to be congruent. And that counts. And then they told us angle GDC this guy right here is congruent to angle HCD, this guy here. and that counts. So now we have 3 check marks. This is where I said to everybody, you know, if the picture's getting too cluttered for you, draw one of the triangles out separately. So I'm going to do that right here. B, D, G. And here's what we have. We have this angle over here, this side marked off, and this angle here. So now we can clearly see why the triangles are congruent. So step 8 is we have triangle BGD congruent to triangle ECH. And this is true by angle side angle. The side is marked in between the 2 angles. All right, well, we have one more step now. The angles BGD and CHE are part of the triangle. So we're good to go here. So sorry, step 9 is angle BGD is congruent to angle CHE, because if 2 triangles are congruent, their corresponding angles are congruent. And we're done. Seems reasonable for the test. Fair game. All right. Number 2. Let me just... Sorry, I just wanted to make the picture a little smaller. All right. So we have AD congruent to EC. AD congruent to EC. Okay. And notice they want us to prove side AB is congruent to side BC. But again, we have to have a plan of attack for this. The plan. We want to get triangles congruent. So which 2 triangles look congruent? Well, these guys right here look congruent to me. So I want to try to get those 2 triangles to be congruent. So AD and EC, if you notice, those 2 sides are way too long. So what we have to do is, since they're too big, we want to subtract something out. And that something to subtract out is ED. But before we subtract the same thing from something, we need to make a copy of it. So we're going to do that by the reflexive property. A lot of you forgetting that. And now we'll subtract. So the big piece on the left is AD. We want to get rid of ED. And that will give us AE. The big piece on the right is EC. I want to subtract ED. And that will give us DC. And then we know that AE would be equal to DC. And this is all by subtraction. And that counts. So now we got this guy congruent to this guy. Check it off. All right, step 4, or given 4. Angle FED congruent to angle GDE. So if you notice what that is, FED is here, GDE is here, and they're outside of the triangles that we want to prove congruent. So I want to number them, call it 1 and 2. Now we're going to try to get into the triangles, 3 and 4, using our linear pairs. So step 5, we have to mention, call this angle 1 congruent to angle 2. We're going to mention, hey, angles 1 and 3 are supplementary. Just for abbreviation purposes, angle 2 and angle 4 are supplementary. And the reason is they're linear pairs. They're on a line together. And now we could say step 6, angle 3 is congruent to angle 4. And for the same reason before, congruent angles have congruent supplements. Or if you want to say, if two angles are congruent, then their supplements are congruent, you can do that too. All right, that counts. So onward to the next given. They told us FE was congruent to GD. And those are in the triangle, so this is exciting. We get a little free one here. Through all this work. That counts. So now we can prove the triangle is congruent. So triangle AFE is congruent to triangle CGD. That's a C. Make that a little neater. And the reason would be, again, if you want to draw one of the triangles separately, you can. Here's what we have marked off. We have this side, this angle, and this side. So we get side angle side this time. Again, the two marked sides are hooking up with the angle that's marked off. All right, so now we can try to get this business of proving that AB is congruent to BC. This is a little tricky, though. They want us to prove that AB is congruent to BC. But AB and BC are too big, and we don't know anything about, say, BF and BG, so we can't try to add them to anything that we know. But let's think backwards for a moment. If AB were to be congruent to BC, then that would make the big green triangle just highlighted isosceles. So now the question remains is, well, how can we explain, using the yellow triangles, that the big green one is isosceles? And the answer is, well, we have angles that are common. So angle A and angle C are corresponding parts of those yellow triangles, which we just proved congruent. So now our step 9 is, angle A is congruent to angle C because if two triangles are congruent, their corresponding angles are congruent. Now, if that's true, which we just explained because we proved the triangle's congruent, that makes the big green triangle isosceles. So in step 10 here, we have a way to explain why triangle ABC is isosceles. And it's because an isosceles triangle has two congruent sides, which we just, not two congruent sides. That's true about an isosceles triangle, but we're trying to explain why this triangle is isosceles. And in the step previous, we were referring to the angles, so we want to refer to the angles here. And since the big green triangle is isosceles, I'm just going to zoom, whoops, didn't mean to do that. I'm just going to zoom out a little bit here. Not that far. Here we go. Since the big green triangle is isosceles, we know across from the equal angles, we will find equal sides. So now we can say in step 11, AB congruent to BC because an isosceles triangle has two congruent sides opposite the congruent angles. And now we would be done with our proof. So that one incorporates a lot of different things that we talked about. All right, a couple more here. Did it again. Hold on one second. View, zoom. Okay, view, zoom. Let's do it that way. All right, so here we have some givens, and we're trying to prove angle FAC. This angle here is congruent to angle FCA. And we have a lot going for us. We have a lot going on in this proof, so let's see. They told us D is the midpoint of AB. Now again, we're going to have to come up with a plan. I shouldn't mark these in here, but that's what we're trying to prove. Now, the plan, there's lots and lots of triangles here that could be proven congruent, or possibly. So what we have to do is see where the givens lead us. If D is the midpoint of AB, so far what I know from that, and this is why I have you do this step by step, is that AD would be congruent to DB. And the reason is that a midpoint divides a segment into two congruent segments. Now, again, what we don't know is which two triangles we're going to set out to prove congruent. But here's the thing. DB certainly is not in a triangle. So even if we said, all right, I want to prove, and I'm not saying we're doing this yet, these two triangles were congruent, DB would not count. Maybe those are the triangles, maybe they're not. Even if I said we're going to set out to try to prove this, whoopsie. Even if I set out and said we're trying to prove this triangle congruent to this triangle. Either way, this statement will only half count. It only half counts because AD is in those triangles, but DB is not. So let's go to the next given. The next given says to us, CE is congruent to DB. Now, we already have one hash on DB. Now we're getting CE involved, and now we're getting into business here. So what we want to naturally say is, hey, this half counts because it's talking about CE. The other one half counts because it's talking about AD. Bring these two together. These are the ones I want to say are congruent. They're part of the triangles. So for AD congruent to CE by the transitive property. That will count. Check it off. All right, now we'll go to the next given and see which triangles we want to prove congruent. So the next two givens are perpendicular, so I'm going to lump them together. So we have AB perpendicular to DC and AE perpendicular to BC. So we have AB perpendicular to DC, which would give us a right angle right here. And we have AE congruent to, perpendicular to BC, which would give us a right angle there. Now, of course, we would get right angles on the above those, but we don't care about those because those angles are not in a triangle. So step 6, we're going to name the angles that are part of the triangles. So we got angle ADF, which is congruent to angle CEF. And this is because perpendicular lines form congruent right angles. And that counts. All right. Now, here's the tough part. We could go with these two triangles, or we could go with, somebody might say, well, hey, why can't you prove these two triangles congruent? We could. We could prove those bigger triangles congruent. But this is where we have to look at the prove and see if we can kind of work backwards. If we prove these two triangles, if we prove these two triangles congruent, this guy and this guy, we're going to get really long segments that we're going to be able to say are congruent. And actually, you know, there's actually two ways to do this proof, now that I'm thinking about it. We could prove these two triangles congruent, okay? Because notice, they want us to prove angle FAC. They want us to prove angle FAC here is congruent to angle FCA, which would be corresponding parts of those triangles. So there's actually two ways to do this proof. We could also use the other two triangles. So I'm going to do this two ways at the end here. You can do it either way. So right now I'll use the two triangles that are in the picture highlighted. So if we're going to prove those two triangles congruent, the next step would be to say, hey, step 7, they share AC. So AC is congruent to AC. And why is that? Well, that's the reflexive property. Now, that gives us a third check. So we now can prove triangle ADC is congruent to triangle CEA. And again, here's where we can draw the triangle separately. I'll pick the left triangle. Here's what we have. I have this marked off, this, and this. This would spell SSA, but since we have right triangles, we can use HL here. The hypotenuse is marked off. The leg is marked off. And then 9, angle FAC is congruent to angle FCA because the two triangles are congruent. The corresponding sides are congruent. That would be one way to do it. That's probably the quickest way. But that might not be the easiest way for some people. So what I'm going to do is I'm going to take this. I'll clone this page. Whoops. Clone it. Whoops, I didn't mean to do that. Smartboard's off a little bit. Undo the add page. I want to take this, clone it, and I'm going to come back to this part here. I'm going to do this a little differently. So instead of using these triangles, let's throw these away for a minute. I'm going to prove these two triangles congruent. So far we only have two checks. So in this case, the 7th step would be for us to, actually, let me just get rid of these angles and this also. Our 7th step here would be, hey, I have vertical angles right here. So angle DFA is congruent to angle EFC because vertical angles are congruent. And now we can prove those two triangles congruent because we have 3 check marks. So step 8 is triangle ADF congruent to triangle CEF by, in this case, angle side. The two angles, if you go from one to the other, the most direct route, the side in between them is not marked off. Now, here's where it gets a little tricky. I want to prove that angle FAC and FCA are congruent. So we want to prove these two angles are congruent. But that would make this triangle here isosceles. So thinking backwards, that triangle being isosceles, it shares corresponding sides with the two triangles we just proved congruent. So if I want to explain why the triangle is isosceles, I can say AF is congruent to FC. Because if two triangles are congruent, their corresponding sides are congruent. So now we know AF congruent to FC, which in turn explains why triangle AFC is isosceles. So step 10 is, well, an isosceles triangle has two congruent sides. And now we can explain why the angles are congruent. So angle FAC congruent to angle FCA, because an isosceles triangle has two congruent angles opposite congruent sides. Woo! So there's a kind of a longer way, but maybe a little easier to understand, and a shorter way, but maybe harder to understand way to do this proof. All right, number 4, we have to draw a picture. So it says in right triangle ABC, AB is perpendicular to BC, so that means B has to be the right angle. And then it says altitude BD is drawn. So it's going to be drawn to the hypotenuse. And they would like us to prove that triangle ABC, a little bit of a different proof here, prove that triangle ABC is similar to triangle DBC. So here we are. Similar proofs are very easy. We need to get angle-angle. So let's see what we have. First of all, they told us AB was perpendicular to BC. Now that only tells us about one angle. Okay? That tells us about angle ABC. So I'm going to say angle ABC, well, right now, you know what? We can kind of group this together. Let me do this a little differently. Let's leave that alone for now, because it's only telling us about the one angle. But then, we know that BD is an altitude. And that's given. We haven't done this, but we're going to combine these two to make an argument. Here's my yellow triangle, I have a right angle. Here's the green triangle, I have a right angle. These two right angles are congruent to each other. So we're going to say, hey, angle ABC is congruent to angle BDC. And why? Well, they kind of came from for different reasons. One came from perpendicular lines, one came from an altitude. But you know what? We can kind of combine that and explain that. Perpendicular lines and altitudes, they do the same thing, essentially, form congruent right angles. So now we've kind of killed two birds with one stone here. We explain why angle ABC was congruent to BDC, coming from both of these things, which are slightly different givens, but basically do the same thing. That's my first check. Now again, we want to prove the yellow triangle similar to the green. Well, what do they share? They share angle C. If you see my highlight, it's highlighting the angle C twice. So this guy is shared. So I should really do this in a different color. So 4, I'm going to say angle C is congruent to angle C. If something is congruent to itself, that's the reflexive property. And remember, for this type of proof, a similar proof, we just need angle-angle and we're done. So step 5, really easy. Step 5 is triangle ABC is similar to triangle DBC. And that's because of angle. So this one might have been a little tricky because you had to draw it and then you had to kind of write the argument, but the idea is not too bad. And I'm going to stop here. I'm going to do the proofs, and I want to post the rest of the answers on Edline.